Okay, welcome everybody. This is Mr. Allen. I'm going to run through the answers from one of the checkpoint quizzes, section 1.3 permutations. The questions obviously are somewhat random and the order might be random, but this is the order that I sort of made them up, kind of easiest to hardest, I would say. So 6-letter words from horsey. So we're using all 6 letters, and if we just kind of do these questions generally using sort of some sort of visual helper here, I'm going to say that there are 6 possible letters that could go into that first spot, the H, the O, the R, and so on. Once I use one of those letters, whichever one I happen to use, it will leave me with 5, and then 4, and so on down the line. And so if I multiply that out, I get 720. The other way to think of this is it's a permutation with 6 elements, 6 of which I'm going to use. So our standard permutation, Smartboard's having trouble keeping up right now, is PNR, where N is the number of items, so it's the total number, and R is the number I want or pick. And so in this case, there are 6 available. I want all 6, P66. In both cases, those multiply out to 720. So continuing on, based on what we just said, this question actually looks pretty similar. We have 8-letter words we're trying to get. From copyrightable though, there are 13 letters available to me. So based on what we just said, it's a permutation with 13 elements, 8 of which I want. And so hopefully that works out to that, whatever number that is, 51 million number. If you don't remember that or don't recognize that, that's perfectly fine. Draw it out. So I've got 8 spots that I need filled. Just kind of thinking about it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And once again, there are 13 letters available in that first position, then 12 in the next because I've used up whichever letter I set in the first position. And as we go, I'll have fewer and fewer down the line. Multiply those out, and again, we should get that 51 million number right there. Continuing on, how many different 12-letter words can be formed using the letters from school is cool? So this is section 1.3. It actually says on the quiz that it's words with duplication. So the big thing is the duplication stuff. When we have duplication, I'm going to run out of room. When we have duplication, ignore the duplication initially and solve the problem as if there were no duplication. So here I'm thinking about 12-letter words. You'll notice if you count them out, there are exactly 12 letters there. That is key to these. And so based on what we saw before, if I do go all the way back up here, I guess I didn't even say it here, this is, of course, also 6 factorial, 6 times 5 times 4 all the way down. And so my starting point here now is 12 letters, I have 12 factorial. If I were to draw it out, I'd have 12 possible first choices times 11 possible second choices and so on, all the way down to 1. What happens now, though, is because some of my letters are duplicated, if I were to swap them in any word that I had, we wouldn't notice a difference. You can picture here with the 2 S's, if we were to swap them, it wouldn't change the word we have. So this 12 factorial ends up being twice as big based on those 2 S's as we want it to be. Similarly, with the C's, we can swap the C's from any letter combination we want, and we'll have a duplicate set of words, or duplicate word in this case. And so we'll have, again, twice as many in the 12 factorial as we want for that as well. With the O's, we can actually swap them in 4 factorial ways. I could put any of the 4 letter O's here, then any of the 4's here, so any of the 4-letter O's here, and I end up basically with 4 factorial. So all that to say, by now we should already know, what we do with duplication is we divide out a factorial for each of the duplicates. So in this case, 2 factorial to cover my 2 s's, 2 factorial to cover my 2 c's, and 4 factorial to cover my 4 o's. And once again, that should be theoretically this 2 million? 2,494,800 number. Moving on to the race questions, we've seen a number of these. Every one of them is different. We have to sort of break down what we're seeing in each case. So here we know that Chris, Dawn, and Emily all finished in the top 3 spots. So basically, we can think of it as almost 2 full races, 2 separate races. Up here, I've got either, Chris, Dawn, or Emily. So one of those 3 people is in that spot. So there are 3 possibilities for first place. One of these people will be in the second spot, and one of those people will be in the third spot. And then over here, we have Alex and Barb kind of filling out the roster or filling out the results. And so if we multiply this through, we see there are 12 different possible race finishes with the understanding that Chris, Dawn, and Emily were the top 3. So we know that Chris finished ahead of Emily. That's all we do know. So kind of looking at this one. So again, there are still, not 6, there are still 5 spots available to us. If we look at we can sort of think of it maybe most easily as looking at this last problem. The key here, we see Chris finished just ahead of Emily. And so what I'm going to do is I'm going to essentially think of them as one block. Chris and Emily, sort of one block, they're going to travel together. My other runners, competitors, characters, whatever you want to say, are those. So now there are essentially 4 different values kind of traveling. There's an A, an Alex kind of out there somewhere. There's a Barb out there. There's a Chris, Emily, and there's a Dawn. So now there are 4 possible first positions. It can be any one of these 4 items. The CE kind of, again, traveling as if it's just one. Once one of those is used up, there are 3, 2, and 1. And so 24 different possibilities there. Okay, so this is sort of a big key. When you know that a couple of items are moving together or traveling together or being placed together, again, whatever the wording of the question is, think of them as a block. And then later on, if you need to, work with that block. So if the question said something like, we know Chris and Emily are finished together, but we don't really know who finished ahead of whom, then we'd still stick Chris and Emily together as one block, but then recognize at the end, but actually, Chris and Emily being together in that order is one possibility, and Emily followed by Chris would be a second option, so I could basically multiply my result by 2 and have twice as many possibilities. So essentially, set up my block, work with the block, and then deal with the block after, if there is some dealing to be done. So again, if those can be arranged different ways, we'll arrange them after the fact. And that'll sort of lead to a final answer that is twice as big in this case, or something else in another.